Hello my dear students, today again we will learn exercise 6a, question number 4, 5 and 6, sums on basic proportionality theorem, page 160, MBOSE Maths book class 10 or Moderns ABC Mathematics class 10. Look, question number 4, what is given? D and E are the points on the sides AB and AC of a triangle ABC. So let us draw the picture ABC. This D and E are the points. D and E are the points on the side AB and AC of the triangle ABC. Determine whether DE parallel to BC or not. We have to find whether DE is parallel to BC or not. The values of AD, DB and AE and EC are given. So let us write this value: AD 5.7 here, DB 9.5 here, and AE 4.8 here, and EC 8 centimeter here. So to determine whether DE parallel to BC or not, we have to find AD by DB, the value, and the value of AE by EC. Let us find AD by DB, what value is coming. So solution: AD by DB is equal, put the value of AD, it is 5.7, put the value of DB, it is 9.5. So this point and point we can cancel, so it will be 57 by 95. Now cancel by 19, it will be 3, cancel by 19, it will be 5. So we get here 3 by 5. And also you find this side AE by EC. AE by EC. AE value is 4.8 and EC value is 8. So first we cancel this decimal, it will be, if we cancel this decimal, here is into say 1, after decimal 1 number it is 10. So it is now 48. Cancel by 8 it is 1, cancel by 8 it is 6. And the 6 and 10 again we can cancel, by 2 is 5 and by 2 is what? 3. So we get the value 3 by 5. What we see? AD by DB 3 by 5 and AE by EC also 3 by 5. It means the line DE divides AB and AC in the same ratio. So converse of basic proportionality theorem: if a line divides two sides of a triangle in the same ratio, the line is parallel to the third side. DE is parallel to the side BC. So we can write here, since AD by DB is equal AE by EC. AE by EC. This also 3 by 5, this also 3 by 5, they are equal. So we can say DE parallel to BC. Therefore, DE parallel to BC by converse of basic proportional theorem. Converse of basic proportional theorem. That is the end of the sum. So this question is, determine whether DE parallel to BC or not. So DE parallel to BC. If we see these values are different, then DE is not parallel to BC, because converse of basic proportional theorem is that if a line divides other two sides of a triangle in the same ratio, then the line is parallel to the third side. So according to that, this is parallel. Look, this question number 4.2. the similar question we have to check whether it is DE is parallel to BC or not. In the same way, we will find here solution C. Here the values given, AD is 7.2 and AE is 6.4. AE, the whole value is given 6.4, and AB is, sorry, here is AD is 7.2, AE is 6.4, AB is 12. This AB, the whole length 12, and AC also whole length 10 is given. So we have to check whether DE parallel to BC or not. So we will take here like this: AD by AB, small part divide by whole part, and this side also small part AE divide by whole part AC. So let us find AD by AB. What value is coming? AD by AB is equal, value of AD 7.2 and AB is 12. 7.2, here 12. If we cancel the point, here is 1. This is in 2. After point 1 number, 1, 0. So cancel this 12 and 72. By 12 here is 1 and here is 6. Cancel by 2, here is 3 and here is 5. So we get here 3 by 5. And look for this side, AE by AC. AE by AC, small part by whole part. So what is the value of AE? It is 6.4. And what is the value of AC? It is 10. So like before, we do here 6.4, we write 64. This is 10. So this is 64. So here will be 10. For point, here is 1. After point 1 number, 1, 0. So this is now 64, not 6.4. And now try to cancel. Cancel by 2, here is 5. Cancel by 2, here is 32. Again this cancel by 2, it is 5. And this cancel by 2, it is what? 16. So we get this is 16 by 25. And we cannot cancel anymore. So what do we see? Value of AD by AB 3 by 5. AE by AC is 16 by 25. They are not same. So we can write here, since AD by AB is not equal AE by AC. AE by AC. So we can say that DE is not parallel. Parallel, then cancel, is not parallel to BC. The reason is same, by converse of BPT, basic proportional theorem. So the proof is finished. So question number 1, they are parallel and this is not parallel. DE and BC is not parallel here because these two values are not same. So let us proceed to question number 5 now. So in number 5, in the figure DE parallel to BC, this is the figure ABC, DE parallel to BC and BD equals CE. BD equals CE, this is given. Prove that triangle ABC is an isosceles triangle. Triangle ABC is an isosceles triangle, that we have to prove. Isosceles triangle means the two sides of the triangle are equal, that we have to prove. So let us take what is given, DE parallel to BC in this triangle ABC. So we write, in triangle ABC, DE parallel to BC. This is given. DE parallel to BC is given. So if this is parallel, then what will happen? This is AD by DB according to BPT. AD by DB is equal AE by EC. AE by EC. This is by BPT, by basic proportional theorem, or AD by dV is equal AE by, look here, the value of EC is equal BD, we can say. So in place of EC we can write here BD. We write here given BD समान CE. BD समान CE. So in place of this EC and CE is same. In place of EC we write BD. This is BD and DB also same. So what we can say, this and this cancel. This denominator and denominator same. So we can write AD is equal AE. AD is equal AE. What we get? AD is equal AE. So now let us find what is the value of AB. AB is equal, see, AB equal, we can write AD plus DB. AD plus DB we can write. AD plus DB. So is equal AD value is what? AD value is AE. So we can write here AE. Value of AD right here AE plus value of DB means BD. BD we can write here, what is CE. This is DB and BD is same. So we write the value of DB. DB is given what? CE. We write here CE. We can write then is equal AE plus CE. Look at the picture. AE plus CE, the value is AC. We can write here AC. So what we see, AB equal AC. In the triangle ABC, this AB समान AC. Two sides are equal. That means the triangle is an isosceles triangle. So I write the next part. Here is I am writing. So we write since in triangle ABC this AB समान AC, AB समान AC, AB is equal AC, AB is equal AC. So in a triangle, if two sides are equal, the triangle is an isosceles triangle. So we can write therefore triangle ABC is an isosceles triangle. That we need to prove. So our proof is finished. So we can write here proved. Next is question number 6. Look, the question number 6. What is there in question number 6? Question number 6. See what is given. DE parallel BC. The triangle ABC is given. Here DE parallel BC. And EF parallel this DC, or we can say CD. It should be CD. Then prove that DA square is equal AF into AB. AF into AB. So just go step by step. See DE parallel BC. DE parallel BC. Look the triangle ABC. In this triangle we can write in triangle ABC DE parallel BC. So according to basic proportionality theorem, we can write AD by we have to prove here this will be AD by AB. Take this small part by whole part. AD by AB, take the small part by whole part. So AD by AB is equal, and this side also take the same, AE by AC, small part by whole part, AE by AC by, have to write here BP T. And again you look also this EF parallel to this CD. So in this triangle ADC, so we write here in triangle ADC, what is given? This EF parallel to DC, EF parallel to DC, actually it should be CD, the DC. Therefore we take the same way, the small part by whole part, AF by AD, and here also take the small part AE, whole part is AC, so AE by AC. Same by BPT, give it number 2 by BPT, and this one give number 1, okay, number 1 this is. So what we see, if we compare 1 and 2, see what we can see if we compare 1 and 2. This AD by AB equal AE by AC, and here AF by AD equal AE by AC. So if we compare this AE by AC, here also AE by AC, that means this and this are equal. So we can write from 1 and 2, AD by AB is equal AF by AD, AF by AD. So, or do the cross multiplication, see AD into AD will be AD square is equal, this side multiply, it will be AB into AF, or we can write AF into AB, AF into AB, and that we wanted to prove. Here prove that DA square equal AF into AB. AD square and DA square is same. If we want, we can just change here, DA square is equal AF into AB. So proved. So thank you my dear students for today. Thank you.